Now if you observe this, while designing this small computer, what are the things we did is, we have first decided upon what are the elements that we want to include in the hardware, the building blocks, like how many registers and what is the bus and ALU and timing and decoder, all this. So we decided about that, and then we had decided about what are the instructions we want to provide. Depending on the format of the instruction, we had decided upon what are the instructions we wanted to provide, and we have boiled down to some 35 types of instructions. And in order to implement every instruction, we are supposed to perform some micro operations, right? What are the micro operations? Like clearing a register or loading something into the register. All those are micro instructions, or clearing a flag or doing that. So in order to perform these micro operations, there are two methods. One method is hardware, by using the hardware. So this one is called as hardware design, okay, or hardware based CPU design, and the other one is by using micro programs, that is called as micro programmed CPU. Now we are talking about hardware design. So in hardware design, what we do is, for every device, what are all the control inputs it will have, and how to trigger those control inputs based on the timing signals and the decoder output. Got it? So if you have to understand it clearly, while explaining about every instruction, I have given you some conditions. Like I told you that if the condition is RT0, then we are going to do so and so, right? And then we have performed some operations there. And now, using this entire list of micro operations that I have written here, right, now we are going to derive what should be the inputs to the control inputs of all the devices. For example, if you have written here something like accumulator, something has to be loaded in this. It means that if this condition is met, the accumulator load input has to be enabled. Got it? So during this time, if this condition is met, the load input of accumulator has to be enabled. Let us say if at the same time program counter is 0, something like this, then it means that when this condition is met, then we are supposed to the clear input of the program counter has to be enabled. Got it? So for all these 32 instructions, whatever micro operations we have written, if you put them together and then see for every register what has to be done, for every flag what has to be done, then we can design the control unit. One such example I am showing you is by taking this this address register. If you look at address register, it is going to have three inputs. One is load input, increment input, and clear input. Now depending on how we enable this, we can perform various operations, right? So if I summarize everything, I got that load input of AR has to be activated whenever these conditions are met, either if it is R-T0. So what is the meaning of it? Whenever it is R dash, it means that it is not interrupt cycle, it is instruction cycle. So in the instruction cycle, in T0, we know that T0 is fetching. So why should we load something into AR register when you are fetching an instruction? Because we have to load the address of the instruction that has to be fetched into the address register. That is why this holds true, isn't it? Now if you go back and see the fetch cycle, I told you that in R-T0 we are going to load AR with PC. Because of this particular load action at this particular time, right, we are going to enable the load input of AR. At the same time, in the bus select input, you will be selecting PC. Got it? That is how they will be done. Okay. And now what about this R-T2? Why are we going to load T2? In T2 phase, why are we going to load AR? Because this T2 is nothing but the decode phase. In decode phase, I told you that the operand part has to be loaded into the address register. isn't it? While decoding, the operand code has to be loaded to the address register, so that in case if it is a memory related operation, we have to get the operand later. That is why. So this is while fetching phase, we need the address to fetch the operand from the instruction from the memory, and while decoding phase, we need the address to get the operand from the memory. Got it? And what about this one? If you see this D7IT3, it means that if you remember, D7 indicates whether it is a memory related operation or the IO related operation, something like that, right? Okay, let's say it is this one, D7 prime. It means that the operation is definitely memory related operation. In case if D7 is 0, it means that it is memory related instruction. So in memory reference instruction, if I is 1, it means we are talking about indirect addressing mode. And if it is T3, so if it is a memory reference instruction and it is indirect addressing mode, and in T3 we are computing the effective address. So if you remember it, while computing the effective address, we get a word from the memory and load it into AR, right? So that is why the load is again enabled here. So if you observe this, if I can put all this in a hardware circuit, then automatically when any of these conditions happen, our load input will be enabled. See this, I am putting all these conditions and I am giving it to load. So if any one of these 3 conditions hold, then load will be automatically enabled. Therefore you need not do anything by program, right? So automatically this will be on, and whatever is on the bus, that will be loaded on, right? So from bus it will be loaded into this. Got it? And similarly, sometimes we are even trying to clear the contents of AR. So where did we try it? See this. So whenever it is R and T0, it means that we are talking about interrupt cycle. In interrupt cycle, we have seen that address register in T0 is made to 0, so that we can store the return address into that particular fixed location, right? Therefore in our simple computer, it has to clear whenever R and T0 is there. That is why if you see this, the clear input is being connected to this, right? R and T0. Check this. This is the clear input. And similarly, we tried to increment our address register. So when did we try to increment our address register? D5 T4. So I don't remember what the instruction D5 was. Let me recollect it. So when did we try to increment? I think it is skip instruction, I guess. So it must be D5 must be skip. I don't remember exactly what D5 was. It must be skip, and we are trying to execute it. Then I think we are trying to increment the address register part. I don't remember exactly what instruction that was. You please check it. But then it required the increment operation. That is why we did it. Got it? So now this entire part, this one, will be a part of CPU. So the main task of CPU is to generate the control signals, right? So in fact it is called as a control unit. So the control unit will generate the control signals, and these are called control signals, right? So what will be the inputs to this unit? So all the timing signals T0, T1, they will be taken, as well as the decoder inputs. The instruction decoder inputs will be given to this logic, and then inside we are going to have the hardware design, and this hardware is going to generate the control signals. These are called as control signals. So this is the design of the control unit. Got it? So we have already the logical units, which are nothing but the address registers and all the other parts, and to these logical units we are giving the control signals at the right time to perform certain operations. Got it? So this is how instruction is going to be executed. Now I'll show you one more example about how the flags will be set. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs universities better than IITs. They have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.